You're working in my field, hence basic questions is that what type of voltage and frequency you expect with your device to put out, not just the power, but the wave and the frequency, because I presume you're talking about alternating type rather than a direct current voltage.
Yes, that's correct. Our device is an alternating current. As far as frequency in hertz, we didn't actually get a value for that from the software that we ran magnetic analysis on, but each oscillation produces about 110 millivolts. So every time the magnet surpasses the copper coil, it produces some positive EMF. Then when it deflects down, it produces negative EMF. So our goal is to implement some type of a power inverter. That way we only harness the positive EMF.
So essentially, you will need to have some products that will take the power from this device and convert it to a power that can be utilized by the users.
Correct.
Okay. The other question that I have is that I would presume in the coastal areas that you have a tide fluctuations, so the mounting of those facilities, whether vertical or whether horizontal, will require some adjustment to maintain them within the peak location that the wave will generate the maximum travel. Am I correct?
Yes, that's correct.
So did you look at some type of adjustment for the mounting of the facility?
Yes. So when we are entering phase 3, we're actually going to construct a device out of the aluminum 5083, and our goal is to implement some type of a microcontroller, such as an Arduino, in order to extend the shaft if necessary due to tidal changes. But that's a little bit ahead of us, so we're still in phase 2.
I'm coming back to my typical question about costs. Sorry. Well, one comment about engineering. You will have to, besides casting, you will have to do some treatment for strength. So casting alone will give you almost an isotropic material. You need to have some strength, so you may have to template or do something with it. But anyway, my question regarding cost is, the device itself beautiful, but I have seen these things in large scales also. How are you going to harvest the energy? You need to have cost for distribution. The seawall costs are not included. You have envisioned this as an individual, like a household device, that somebody will have their own thing, and the seawall, okay, I'm going to go and connect my own thing there? Or you think there's going to be more of a community, like a city will install that in a large scale, so that will be implemented? I think it's a great solution, by the way, in coastal towns. Also, storage, batteries, inverters, all these procedures. This on itself could be a method of generating electricity, so it's not an individual thing. But your costs are looked at how much it costs to make a small thing. You need to look at this in industrial strength, because to build a seawall is a very expensive project. You're not going to get $3,500, maybe a few $1 million. But in itself is a great solution. So I don't know if you have considered this in a large scale, or why did you dismiss, for example, the seawall cost or the electricity cost, I mean the distribution cost and things like that?
Would you like to answer that?
Sure. So we did take in consideration both factors. Our initial approach was that we were going to implement this device on already existing seawalls. Our original idea had this to serve in individual households, such as ones that own boats on the sides, whatnot here in the States. But we found that that was a little bit rare in Cuba. So this would do good on, say, coastal communities, such as the places that we listed above. And the price, well, that will probably be for a specific niche of people that live in Cuba for, I guess, what they make annually, and probably for smaller companies that want to increase their revenue and awareness on the community and the environment.
I think it would work great in a large scale. I'm not so sure it's going to work on a small scale like you propose, but in large scale, beautiful.
Thank you.
I just really wanted to compliment you guys on a very innovative concept, and I think that's what this project is all about. So thank you very much.
Just out of curiosity, because this is not my field, the dimension of the device, how did you guys determine it? Was that the optimal dimension to get the output you wanted, or does the size matter?
So initially, when we thought about this device, we took into consideration what is the distance between the mean water level and underneath the dock. So it was approximately 1 meter. So our device is about 1 meter, 1 to 1.5 meter. But that's subject to change because depending on the applications, you would need to extend the size, make it longer, make it shorter. And that's why I mentioned the microcontroller. Maybe we can control that remotely.
If I can comment as well, that size also allows you for a greater mobility to the clientele. So say a hurricane were to come, this device is not built to withstand such hurricane forces. You can easily go out and take it out. You're just a one-man deal.
Great. At this time, we can open it up to questions from the audience. So we have a question back there. Can you come around and ask the question here for the microphone? Come up here.
Hello, great job, you guys. So I have a question regarding. This is good? Okay. So you spoke about putting this in hotels near the coastal areas. So how will the rotation speed and energy affect the environment and organisms living in this water? And second question is, how will it affect the structural stability of the sea bar?
All right, so to talk about the environmental aspect, we are using an anti-fouling paint, and majority of those are non-toxic to the environment, or at least should be, and the ones that we are looking at are non-toxic to the environment. Besides sea life, when this device oscillates, waves are coming from every direction, so it produces this sloshing effect back and forth. I don't think that it'll be too hazardous for nearby sea life, and because microorganisms love to inhabit certain things, it could even produce more marine life, such as for reefs. So.
Any other questions?
Great presentation, congratulations. Yeah. I was wondering, what's the maximum wave height that the current device can withstand, and what is the return period for that wave height, if you evaluated that? So if a wave comes in that you can't remove the device in time, what is the maximum wave it can withstand?
The maximum wave height it can withstand is around 6 to 7 feet. Yeah.
And if you have to, you have a hurricane, then what's the procedure there?
The best thing about the device is that it can be detached easily, and you can detach everything and you can take it. And once the hurricane is over, you can again attach it back. Yep.
Okay.
I also wanted to mention the structural integrity of aluminum 5083. It's very strong. It's very susceptible to wave energy, waves itself. So it'll hold up in such harsh conditions. That's why we decided to go with that. And also it's a marine grade series alloy. So.
Thank you. All right. Give it up for team from FIT.